Welcome to Security in the Fast Lane, a monthly conversation on improving security outcomes, creating a culture of security, and building subject matter expertise. Brought to you by NTT Application Security with your host, Setu Kulkarni. Joining him today is Matias Madou, CTO and co-founder of Secure Code Warrior.
I'm sure every one of us has suffered what is called the writer's block. How do I finish that email? What should the next slide say? Or in my case, how do I write the opening narrative for this podcast? I use the example of the writer's block to make a similar argument for what could be called the learner's block. Many times we understand the core need for more knowledge, particularly in the case of cybersecurity, but more often than not, we don't know where to start. I argue that everyone in the world, everyone, should be cyber aware, at least to a basic level. But the question is, where does one start to learn? And it's not because of a dearth of content. In fact, I believe there is more content than one can consume in a lifetime. So in today's conversation with Matias, I'll explore this topic of the learner's block and find some ways to address the learner's block in the cybersecurity context. We won't boil the ocean, so to say, because doing that, I think, will not get us to the bottom of the issue. So we'll address the issue of where do I start to learn about security and how much do I need to learn about security for a small but powerful community, software teams. But first, Matias, let's begin with learning about your journey in co-creating Secure Code Warrior. What are some of the inflection points, the important turns that you had to make to get to this point?
Absolutely. Thank you very much for having me on this podcast, Setu. So Matias Madou, I'm the CTO and co-founder of Secure Code Warrior. I actually started my career at Ghent University here in Belgium, where I pursued a PhD in application security, and I was mainly working on static analysis. With my PhD, I moved to the US, joined a company called Fortify, and what we were doing for the next 7 years, I was spending my time trying to find problems in code. And I think we did really well. I think we did really well in finding problems in code. However, at the end of my journey, I started to realize hey, it's actually fairly easy to find problems in code if you never ever tell a developer how to code securely in the first place. And also, the tool wasn't really used to the best of its strength because the tool was finding all these, rather simple problems if you know how to code securely. So it was finding all these fairly simple problems and not the complex problems that it was intended to do. So I jumped ship, and together with a group of very knowledgeable people, we started Secure Code Warrior, where the entire premise, the entire idea of Secure Code Warrior is to help the developer in writing secure code, and essentially get the security team off their back. So that is our mission. We just want to be there. We want to be positive around security. We want to help the developer. We want to be there with him. And essentially, we want to be there from the start.
Perfect. Actually, I'm going to pick up on a strand here around developers not knowing that they're actually writing bad code, right? Or insecure code, and it's easy to then pinpoint issues. There's another angle that we've been exploring here, and we've done a podcast on this, around first and foremost, developers don't know that they're writing insecure code because they've not been taught, and that's kind of the topic for today's conversation. But also from a product requirements point of view, the abuse cases have not been presented to them. So there is no incentive, so to say, to start thinking about how the application that they've written or developed can be abused. So I think both of those are kind of meaty topics to dig deep into. So with that said, let's start with some data, right? We obviously do a lot of analysis on our end around application security vulnerabilities. And what we find, Matias, is that the top 5 vulnerability classes that we identify has actually remained quite constant over a long period of time. Information leakage, insufficient session expiration, cross-site scripting, believe it or not, insufficient transport layer protection, and content spoofing. These are the top 5 vulnerabilities we find consistently over a long period of time. And my argument is that, look, these are pedestrian vulnerabilities. We've known about them for a long period of time, and they have actually remained quite static and constant. Could organizations use this data to start designing a targeted kind of education campaign to start off to help their developers understand how to write more secure code?
So, absolutely. But at the same time, so first of all, I'm not surprised that you're seeing similar categories over and over and over again. Because I think we're not addressing the root cause today, which is going all the way back to the developer and helping the developer. So I'm not surprised. But what can we do about it is essentially the question. I think what we can do about it, if we really want to tackle that, there's first of all the idealistic world in where you're going to fix the problem in the framework. If you can fix the problem in the framework, fantastic, do it. Unfortunately, quite often that is not the case. You cannot fix it into the framework because we're building code on top of broken code, on top of another piece of code. And unwrapping that is very hard. We're very rarely starting from scratch. So the next thing that we can do is we can help the developer and educate the developer, but we need to do that, in an efficient way and in en masse, essentially. So how can we do that? Well, we can, if we know about the top problem in an organization, and I would assume there's a little bit of variance in your top 5 within an organization. So every organization has its own top 5. What we like to do is we want to take that number 1, and we want to roll out a training program that is very relevant to these developers. What does that mean, very relevant? Well, it actually means that if you're a Java EE developer, you can take training in Java EE. If you're a COBOL developer, well, you should be able to take training in COBOL. That means, that is to me very relevant. So we need to make sure that we tell the developers something that they can use instantly, that they can use tomorrow. So it also should be, usable. It should be, directly applicable the day after. So that's why we need to be framework specific. Java EE and Java Spring are 2 different things. So we need to be actually framework specific if we're going to teach a developer how to write secure code. So to me, if you want to do that, you have to do that at scale. You have to do that in the language and the framework that a developer is using. And at the end of the day, 3 months in, if every developer is educated on that front in an efficient way, well, then you can actually jump to the number 2 on that list. And, well, it will normally become number 1 because your number 1, you have actually tackled your number 1. And that's how you can do it step by step, but move towards, a decent state of your code. And I hope that if we do that, that you see a different top 5 a couple of years from now.
I have a few kind of follow-on questions to that. And the first one is really around, is this bold enough, right? I completely get the idea that let's not boil the ocean. Let's look at the top vulnerability or vulnerability class. Let's narrow it down to what programming language, what particular frameworks you're using, and then go ahead and train the developers. But is that bold enough? And maybe another way to ask this question is, arguably, you've taken this approach across hundreds of customers. And what are the kinds of results you see by taking this small action, right? It is a relatively narrow, specific action, but does this kind of create an outsized impact?
So I do think it's bold enough. And the reason why it is bold enough is, I think all too often, companies want to boil the ocean. Let's be honest. If we're talking about tools, they're not going to ask you, like, if we have one big problem, how can we solve that? No, they're going to ask the question, like, how many problems can you find? How many different categories can you find? And they want to find more and more and more. At the end of the day, that is not very helpful if you're not fixing the problem. So what we're doing is we're taking an opposite approach. We're doing small steps at a time, but they are very, very effective. But you need to do that, in a scalable way. So for when I said, hey, you know what, you have to roll this training program out to all the developers in the language and the framework of their choice, we're not talking about a lot of customization. No, it's just saying, hey, you know what, we want to tackle SQL injection, send out an email to everybody that they have to be trained on SQL injection. But if they go into that platform, they're gonna narrow down what language and framework they're gonna be trained in, and that should be the language and framework that they're using on a day-to-day basis. So I'm a very big fan of taking small steps at a time, but do it right, do it effective, so there's a measurable impact instead of trying to do everything at once, because quite often that does not work.
So that kind of brings me to my next question. Let's say we've kind of made this analysis and we go to someone in the organization to take this bold action, or to take this bold specific action, so to say. Who decides this, right? Is it the chief information security officer, or is it the VP of engineering or director of engineering? Because oftentimes what I've experienced is there is an accountability gap somewhere in the entire security implementation. So in your mind and in your experience, who's the best person to make this decision? Is it the security team who's actually seeing these issues on a day-to-day basis? Or is it the director of engineering, the VP of engineering, who says, hey, you know what? I should be really looking at security as a quality issue and I need to take steps?
Very good question. And my honest answer over here is I hope it is the VP of engineering, but quite often it is the application security team that makes that decision. I personally think that not a lot of engineering teams have moved on from, hey, they know they have to write qualitative code and they know it has to be performant. But in terms of security, they are quite often not there yet. And quite often they still rely on the application security team to tell them what is good for them and what is not good for them. So I hope it is the VP of engineering, but right now, as you said, so it is quite often the application security team that makes that decision.
Okay. Now, as a thought experiment, right? How do you feel about addressing this gap using some other roles in the software development process? One role that comes top of mind is quality control engineers, or QA engineers. Now, QA engineers spend most of their time trying to break software to make sure that when the software is actually in production, it performs as per specification. So, how about taking this kind of approach of training the right people to the QA engineers? Do you think there is a benefit there?
Oh, absolutely. So I think everybody in the organization has to rally around security, top to bottom, bottom to top. So QA plays definitely an important role over there. But actually, it all starts with management. Management has to really make that a priority in the organization and say, hey, you know what? We take security seriously. Our customers, they put trust in us, and we have to honor that. So we have to make sure that we build something that is reliable. And in the reliability, it also means security. So yes, QA is in there, developers are in there. So if they make that decision, developers and QA should be given time to upskill themselves and make sure that developers know how to do the right thing, and that QA can help in, well, potentially pointing out problems. And maybe to tie this back to one of your initial comments that you've made, quite often showing the impact to developers and to QA will get them over the line to think more about security. They don't have to hack themselves. That's not what I'm saying. But they should understand the impact of bad code. They should understand what a SQL injection can lead to. They should understand what a cross-site scripting can lead to. And once they understand and they figure out, like, hey, this can be potentially a big problem, and especially in terms of trust for the customers that are relying on our software, then it's a much easier conversation for the developers and for the QA organization to rally around writing secure code.
Right. And before we move on to the next topic today, I wanted to pull on that a little bit more, right? So I agree that it has to start top down. And I actually think that organizations now more than ever are doing a pretty decent job at least at the board level, at the management level, calling out security either separately or as a part of reliability. But where I think we're missing the boat and we're missing a couple of tricks is how do you translate that high level, board level, company level objective of being secure, being reliable, being trustworthy into product requirements that developers can see in front of them and start writing code that meets those security specifications as well. So, long question, but more directly, how about training product managers?
Oh, so good. So good question. So how do you connect the board level to the developer? And it can go wrong in a lot of different places. Product managers is definitely an area because well, quite often product managers think inherently that security is there, and just like hey, they think it is performant. What developers will do is performant. It is secure, um, and they think that code is just developed that way. So quite often, yes, they do forget about that. I also see another one, to be honest, where there's a disconnect and where people where it drops off, and that is even between the security team and the developers themselves, where the security team tells the developers how to do it or says, we have to write secure code. But then there's really a gap between the developer and that security team because they do not know how to do it. And maybe one thing that I can suggest over here is think about filling these gaps with, for example, security champions that bridge the gap between security and the developers, and also that would benefit the product managers when these security champions can also educate the product managers, like, hey, you know what, we really have to think about that. It doesn't come out of the box. Quality doesn't come out of the box. You think it comes out of the box, but it doesn't. But if we put the right processes in place, if we put the right skill sets in place, if we make sure that our developers really upskill themselves and think about that, well, then we can actually do the right thing. But it is a little bit of an investment.
Makes total sense. Good point though, right? We need to start thinking about not just training people, but also identifying the gaps that exist between teams and roles in the organization. And I think the security champions idea is a great one to plug those holes. Let's kind of shift our focus to something that's slightly more well known, right? And I'm talking about the OWASP Top 10. What we've found, particularly over the last couple of years, is that security awareness has actually increased from the levels from before, right? In the sense that developers, QA engineers, product managers have the notion or understand the notion of the OWASP Top 10. They may not understand each one of the OWASP Top 10 categories, but they know that there is something called OWASP Top 10 that can be used to assess application security vulnerabilities. Now, where I want to take this conversation is, in your mind, in your experience with the work that you have done with hundreds of companies, what is the effectiveness of taking a OWASP Top 10 driven approach to security? For one, we find that, for example, security misconfiguration is the most relevant and most occurring category from the OWASP Top 10 in the analysis that we've done.
So to the original point of your question, indeed, the OWASP Top 10 is very well known. It is very steady, if I can call it that way, throughout the years. Over the last 10, 15, 20 years, it's the same things that pop up in roughly the same order. So it is very, very static. What I always recommend to organizations is to figure out their own top 10. We can say, hey, this is the top 10 based on all the knowledge that we have, but organizations need to figure out their own top 10. And I think I agree with the fact that security misconfigurations are bubbling up more lately. My personal feeling is that that may have to do with the cloud infrastructure as code. Everything is a configuration these days. So in that particular sense, it makes sense that configuration mistakes are bubbling up or more quite often. Um, Maybe to add one thing in there is, from our perspective, there's the OWASP top 10, and that's about the web. What we see is in certain languages there is not really a match for the OWASP top 10. Let's say COBOL, a very old language. There is no OWASP top 10. It's not even web. So it is very important for every organization, I would say, to figure out their own top 10, and quite often that's going to align with the OWASP top 10. Don't get me wrong, but certain languages, they are just not fit into that specific model, and then you need to figure out your own top 10. And if that's the case, I think with more and more going to the cloud, I think misconfiguration will definitely bubble up more in the next couple of years.
That's right. Let me kind of ask you a trick question here, Matias. I kind of understand this whole idea of what I call the tsunami of the past, right? It's great that everything is moving to the cloud, and maybe in 5 years or 7 years' time or 4 years' time, maybe the majority of the applications that we use have moved to the cloud and are using cloud native principles. But to your point, there's still a lot of code that is written in legacy programming languages. And when I say legacy, I'm talking pre-Java. In that kind of an environment, how do you create this concept of security champions? Because there might not be even enough people who understand COBOL, for example. So how do you think we can address that gap? Because there is a significant portfolio of applications that are still kind of out there in production, potentially exposed using APIs. Somebody's created a layer of APIs on top of that 30-year-old legacy COBOL code base. So how do you kind of engage security champions to actually go do the translation that is required from security requirements to patching systems that have very little expertise out there?
Yeah, so very good question. But so I'll be honest, we had a very tough time finding people to make training challenges in COBOL. We had a very long search, and we were very lucky to find one very young guy, and then also a retired person that was willing to help us out in writing COBOL challenges. That's fantastic. So if you have that knowledge, we cultivate it. We have a lot of good challenges in COBOL, and then it's up to these organizations, and we help these organizations if they roll it out, if they go into these COBOL teams and they take the training. I'm pretty confident you will find a security champion, and it's not going to be it's not necessarily your top-notch developer or your most technically skilled developer. In my mind, the security champion needs more than technical chops. He needs to help the others in the organization. He needs to be able to explain something very simple that other people can understand it and they know what to do. So for me, it's rather irrelevant from the coding language. It can be a very old one. It can be a very new one. As long as there is a good fundamental basic piece, it can be training, it can be a document on how to do it, and you can identify one person with technical chops but also with social skills to help the others in the organization, and that's how you start. I think that's how you start.
Right. So what I'm kind of taking away is, first and foremost, as the head of engineering or a head of security, you got to understand, you need to have an inventory of the technologies used in your application stack. And once you've done that, lean on people who've got good social skills, good technical skills to kind of bridge the gap.
Sure, but unfortunately, I have to say, a lot of organizations, they do not know their technology stack. Quite often, we go into organizations and we ask, "How many developers do you have?" And they're like, "Well, maybe 1,000, maybe 5,000." And how many? Like, what are the technologies that you're using? Well, Java, .NET, the typical ones come up. But then, quite often after the fact, we figure out that this team over there, somewhere in another country, is using some technology that they were not even aware of. And I presume you see the same thing in terms of applications. How many applications do you have? Well, 100, 200. But once you start to make an inventory, it suddenly seems to be 500.
Exactly. Actually, I'm reminded of a few years ago when I used to work at an application company. We would always go to customers and talk about, hey, you know what? We are a polyglot hosting environment, meaning we don't really care what development language you use, right? Whether you use Scala or a fourth generation language or COBOL or Java or Ruby, it doesn't matter because we can host anything. I think this whole idea of virtualization, containerization has created that abstraction layer where developers can actually be polyglot.
And can I add one more thing to your question, because I found it quite interesting that you say, hey, right now we're moving everything to the cloud, but we've seen this already where we moved everything to the internet, where we started to connect things that were not made for the internet to the internet. To give an example, the grid. We decided, like, hey, would it not be a fantastic idea to connect the grid or the pipeline, the hack on the pipeline, the ransomware, where suddenly the oil wasn't coming out of the pipe anymore. Well, we were connecting things to the internet that were not made for that, and now I think we're doing the same thing with the cloud. We're moving everything into the cloud, and guess what? It was not designed for that. It was not designed to be moved into the cloud, but we're doing the exact same thing. Hopefully we learned from previous experience.
Exactly. I call that cloud washing. But but let's kind of move on to the last topic for today. And I think we've addressed a lot of this in the conversation so far, but I'd like to kind of focus on this a little bit more around embedding education within kind of the entire life cycle of the organization, and also identifying the right stakeholders who need to be trained. We spoke about CISOs who need to be trained, but at a very different level. They need to be able to translate the reliability mandate, so to say, to security requirements, maybe train a couple of security champions that can then go work with product managers. The QA engineers should be looking at security. Obviously, developers and DevOps teams. So now we've kind of expanded the scope of security education from that small community of software developers to this big, large virtual team that not necessarily reports to one individual, but actually has a role to play in making a product successful and keeping it successful in production. So, kind of a long question, but basically, I'd like to pick your brain on what's the best approach to embed security education throughout the organization, and what's the best approach to engage all the right stakeholders to come to the table and get educated.
Oh, that's a good question. In my mind, you always have to think about the end product and the trust that you build up with the customers that you ultimately have. And if you understand that, I think it's going to be automatic that the culture in the organization is going to change. What can help drive that culture is, well, there's only actually two things that I can think of that can help drive that culture, and that's either your neighbor got hacked, which means your competitor got hacked, and you look out the window and say, "Oh my God, yeah, we cannot afford something like that. We have to make sure that something like that is not happening into our organization." So that is the good one. If your organization gets it because a competitor is burned, that is the good one. The other one is, well, you got hacked yourself. There was an incident, and suddenly you start to realize, well, you know what? Maybe we should invest into that. So these are like the two main drivers that can help install a security culture into an organization. And once one of these two happen, there's always the exception where an organization is proactive, but you see that less and less, right? The honest truth is that you see that less and less. But once one of these 2 or 3 events happen, then it's pretty obvious, it's pretty trivial that the organization is gonna rally around security. But then still the thing comes up like, hey, how much do we have to invest in security? What is a good amount to invest into security? And that's a very tricky question. It's a very tricky question, and then it comes down to figuring out where you get an ROI, figuring out my strategy has always been, there's not one silver bullet. So my strategy is to optimize your budget and make sure that you do something of everything. To give an example, make sure your developers are trained so that they do not introduce 80% of the problems. Make sure you invest in a static analysis solution to make sure that you find the hard to track problems. Make sure you invest in a pen testing solution, because after the fact, you can do as much as you can. There's still these hard to find things that pen testers can find. So you really need to spend a little bit on everything to make sure that the right tools, the right people are finding the right problems into your organization.
Right. I think that's kind of a broadly that's true, right? You've got to be able to do a little bit of everything, and the sum of parts kind of then is much larger. But if I had to double click on the security training aspect, right, making sure we're able to bridge that education or knowledge gap in the organization, is there one or two things that you've said to a chief information security officer or somebody who's responsible for overall security, and that individual has said, aha, that makes sense and that's easy to implement? Is there a silver bullet? Let me put it that way. Is there a silver bullet, at least as far as convincing the leadership in any organization to start thinking about security education? Because I think that's quite topical, because look, we know the problem really well. We have a report that tells us what are the top 5 vulnerabilities. We have the OWASP top 10, and potentially the AppSec team and the security team can come up with their own top 10. But the knowledge gap still exists, and how do we convince or motivate the right leaders in the organization to take that one small step which is going to change their destiny, so to say?
Mm-hmm. So in my mind, the one small step is we need to think about what we're doing, and ultimately everything is code, everything is bits and bytes. And if you think about security, you can buy security products, but again, you're buying software to protect software. So at the end of the day, you have to think about this and say, well, maybe why are we building software to protect software and building layers around software, which is again software? Why is this stuff broken in the first place? And what can we do about it? Maybe that's a good starting point, to go really back to basics and figure out what the root cause is over here. And quite often it comes down to, what, security education. If people come out of university, they know how to program, they know how to make something functional, but application security training is, in what I've seen at universities, still very, very minimal. At the same time, when they come into an organization, we give them a laptop, we give them access to the code, and we say, program, write some stuff, write some functionally good stuff. And that's where it all starts. It starts with making sure that top leaders in the organization understand that we're building software on top of software, and we build software to protect software. It is software. It is the software. So let's look at the software. Who's making the software? Can we help the people that are making the software? And if they understand that, I think quite quickly they will understand why they need to invest in training and tools to help building the right things.
Yeah. So you're talking about the vicious recursive spiral, right? Software to protect software to protect software. And you've got to be able to break that cycle. And a cost-effective way of breaking that cycle and scaling the benefits is education. So I think that's a good key takeaway. Matias, this has been great. Let me quickly recap our conversation and see if you have anything else to add. First, you spoke about when you look at problems in code, the idealistic approach is let's go to the framework, let's go to the design pattern and fix the framework, fix the design pattern. But that's often a pipe dream because it's very difficult to do. Code is built on top of other code, which is built on top of other older code. And making that framework change is difficult. So the idea here is, let's start looking at one or two vulnerabilities, the most critical vulnerabilities, and take a small, bold step in addressing that vulnerability top to bottom. Then we spoke about OWASP top 10, and we soon kind of came to the conclusion that OWASP top 10 is a great list, but much like our own list, it has remained relatively static. And what organizations need to do is look at OWASP top 10 and other benchmark metrics, but very quickly pivot to figuring out what their top 10 is, what their top 5 is, because then they can start taking some focused action. The interesting part of the conversation for me was also when you spoke about how there are programming languages that are legacy programming languages like COBOL that need to be addressed from a security knowledge gap perspective. And the first step there for organizations to take is to get an inventory of the application technology stack and then identify the right security champions to go and bridge that gap between what exists and what are the vulnerabilities that are showing up, and get people behind this idea of fixing those vulnerabilities at the right spot. And the last piece, which was a key takeaway again for me, was you spoke about how sometimes your neighbor got hacked. That's why you do security training, or you have somehow figured out to take a customer-first approach at security, which is quite rare. But the best way from a leadership point of view to start introducing the idea of education is to recognize this vicious recursive spiral. You're building software, and then you're buying more software to detect vulnerabilities in your software, and then you're buying more software to mitigate vulnerabilities. So you've entered a vicious recursive spiral. And to break the cycle, you need to start thinking about security education, educating the right people across QA, product management, security, leadership, to start thinking about security. So that's kind of the summary of our conversations today. Anything that you'd like to correct or add to that takeaway?
No, fantastic summary. You either have a very good memory or you're a really good note taker, but that was a fantastic summary.
Perfect. Thank you, Matias. For our listeners, be sure to check out our monthly stats flash, where we actually dig deeper into what we're finding on a monthly basis from a state of application security perspective. That's a good complement to today's conversation. And finally, thanks to my producers, Lauren and Herman, you make this really easy to do.
Thank you for listening to Security in the Fast Lane, brought to you by NTT Application Security. To learn more, visit us on the web at www.whitehatsec.com.